Hello, my name is Brian James, and I'm a product specialist at Sensible Technologies. This is Freeform Modeling Plus version 9. The following demonstration will give a brief introduction into how Freeform can be used to create medical implants that match perfectly with scanned data of a patient. On the screen here we have two items. The light tan one is the imported polygon file converted to virtual clay of a pelvis of a patient, and the purple body here, the cup, is an implant designed in another package and imported as a parasolid file. I'll hide the parasolid here in the object list for a second to show you the injury to the patient's pelvis here. This section, this pocket called the acetabulum, is corroded and needs an implant. That cup is the implant. The use of Freeform here is going to be in constructing tabs that come off of the edge of this cup and mesh perfectly with the scanned data, the bone of the pelvis of this patient. I'm going to go ahead and show you a workflow that involves half a dozen tools or so in Modeling Plus, and the first one is going to be a curve drawing tool. So I have this pen stylus here, and I can physically go in with the Phantom desktop device, and I'm physically touching this cup here, and I can rock around on the inside of it. I can also feel the clay of the pelvis as well. What I want to do is I want to draw a couple lines, a couple curves that are going to span this distance between this edge and this edge. But before I do that, actually, I think what I need to do is extract curves off of these edges. So I'm going to take the Extract from Edge tool and just select 1, 2, 3, 4, and I'm going to go back to our pen drawing tool. And now I have two curves that I can touch, and I physically, haptically, we call it, snap to these curves. So it's very fast to make your way around in the program with the use of touch. I'm also going to specify that these are going to fit to the surface of this solid, as well as split any curves that they come in contact with. So here I'm going to make 1 click, 2 clicks, and 1 click, 2 clicks, and you can see as I highlight these curves here, just by mousing over them and touching them, that there are 4 individual curves now. And I'm going to do the same thing over here. These are representing these spots where the tabs are going to come off of the cup here, that is the implant. And I'm going to do one more over here. So it's very fast to lay out the position of where these tabs are going to come from. The next thing that I want to do is I want to create some additional curves, but these curves are going to be fit to the pelvis. So instead of, let's delete that, instead of fitting to the solid, I'm going to click this button here, which is Fit to Clay. And so let's do this curve network right here. I'm going to fit these curves to the clay. 1, 2, 3. And hit E to end that curve, and 1, 2, 3, 4 down here. And all I really want to do is make, if you imagine the end of the tab, where it actually makes contact with the pelvis, that's what I'm drawing out here. And so I'm haptically snapping. I get that physical snap into those edit points, so it's really fast to know when the curves are touching each other and lined up. I'm using a hotkey, the letter S, to actuate the Select tool here. So I can go and touch that curve, and you see that I have the handles, the tangency handles, that I can physically touch and pull out. All the time this curve is remaining stuck to the clay. It's stuck to the surface there. So if I rotate a little bit like this, you can see these curves, even though I was touching the clay, are fit to the clay. They are sucked down onto the clay. And we're almost done with laying out the geometry of this tab. The next step is to go into our curve drawing tool. Again, I seem to have broken that, so let me just refix that for a second. There we go. And I'll go into the curve drawing tool again, and I'm going to turn off Snap to Clay because I want these curves to be free floating in space. And I'm going to make 3 clicks here. 1 at the beginning, 1 at the end, and 1 in the middle. So 1 in the middle and 1 at the end. And now I'm going to go back into that Select tool and I'm going to reposition these curves. This is the area of the underside of the tab that will loft over this acetabular periphery ridge. And what we're going to do here is just take these tangency handles, and I get that snap when I'm tangent to those adjacent curves as well. And I'm rotating using the G key and the movement of the haptic device to simply orient my view so that I know how this is going to undulate across the surface. So let's go ahead and create tangency as well with this shared curve right along there. And what I want to make sure is that I give enough room around the acetabular periphery so that in the operating room anything that's been changed using the ball-shaped reamer to dig out any adjacent bone material, that anything that's changed from the time that the scan was taken won't be affected. That's why the area of the tabs that's fitting to the clay is actually down here on the pelvis. So we're ready to go into the next function, which is I'm going to create some NURB surfaces based on these curve networks. And the first surfaces that I'm going to create are not going to be fit to any clay. They're simply going to be representations of their boundaries. So you can see here that that surface that was created using those free-floating curves is not sucked down to the clay. Now for this surface here, I'm actually going to specify to fit to clay. And I'm just going to say OK. Oops. Just undo that for a second. I didn't want to fit that, so let's go back, and I'll leave that function for a second, re-enter it, and this time with the settings of fit to clay, I'll choose that boundary, and that has now been sucked down to the surface of the clay. I'm going to raise my patch display properties a little bit here so that you can see the surface that I just created a little bit more tessellated than the default setting with a higher degree of tessellation. And now we have three surfaces. There's one on the edge there, this one over the ridge, and the one that's fit to the scan data of the pelvis. What I want to do is I want to take these three surfaces and stitch them together into one surface. So right now I'm going to do that just by clicking All down here and stitch those three surfaces together. So now we have three surfaces that are stuck together. Only one of them is fit to the clay, and it's represented here in the object list. What I'm going to do is, in my patch display properties, I'm going to turn on something called Shade with Backface Color. And you can see that what that does is it shows me the direction in which this surface normal is pointing. And that's important to us here because we want to thicken this collection of surfaces into a distance of a few millimeters that will represent the thickness of the tab. Red is the direction they'll thicken to, so everything's fine. If they were pointing in the opposite direction, I would simply go into the object list and select Flip here for that patch, and it would be stitched to the direction of the normal would be flipped towards the clay instead, and therefore any thickening would occur in the opposite direction. Here I'm going to go into a function where we thicken this sheet, so I'll select the sheet in the object list to select all of it at once. And then I'm going to go down here and select an edge sharpness of 0.35 millimeters and a thickness of 5 millimeters. I don't know, actually let's make that 4 millimeters, and then we'll say OK. We'll apply that, and what that's going to do is create a thickened representation of this surface in virtual clay that then we can sculpt and model however we see fit. And you can see the representation here. What's happened to the patch, however, is it's disappeared and it's been replaced by a piece of clay. If we wanted that surface data, we would just export it simply as an IGES surface before the thickening process as well. Here I'm going into smooth out these edges simply by touching them, and I have a smoothing tool right here, and I'm just going to walk along the surface and smooth it out manually using the Phantom desktop device to touch the edges of this tab I've created. Anything that's implanted in the body, obviously we don't want any sharp edges on it, so we're going in and smoothing out the geometry so that it's as amorphic or organic in nature as possible. Now this was a very straightforward layout method for the tab here. In terms of its shape, it's very rectangular, but the options are limitless. and the type of geometry that could be created here. The usefulness of this model immediately can be seen with the use of rapid prototyping machinery. In addition to freeform, we can mill or RP a prototype of this implant, or we could actually RP the direct implant itself if we were utilizing something such as SLS technology and printing out in a metal alloy. So here we're simply just smoothing out all these edges and getting it to be as doughy as possible so it's friendly on the inside of the body. Now the portion of the tab that is not clay at the moment is still this solid, and what I want to do is just show you briefly how we can combine this tab into that solid. So we're going to convert that solid, just like we did the sheets, to clay and then combine it to this tab. But very quickly you can see that we have geometry now that rises over the acetabular periphery and fits to the geometry of the pelvis in a very, very short modeling period of time. So let's go ahead and select this solid that we have here and convert that solid to clay. We're going to choose the exact same clay coarseness setting of 0.35 millimeters. It seemed to be a good resolution for the patch, for the surface of the tab rather as well. Now the difference between creating a clay version of the solid is that from creating a clay version of a patch is that the solid remains, and we can go back to that at any point in time. The representation of it as clay here is this bottom piece 3 in the object list, and what I'm going to do is I'm going to say combine into this piece here, which is the tab that we just created. So I'm merging these two clay bodies into one, and let's zoom in here on the juncture, and you can see how they've started to mesh together. Let's turn off all our curves for a second here so we get a better look. I'm going to go in here with the smoothing tool again and simply touch that area and smooth out that geometry. You can do this in a number of ways. You can do this manually like I'm doing now, or you could, we'll undo it, we'll do it a different way. You could paint a selection area right here. Let's just make this a little bit smaller. So you could just simply paint a selection area. I'll get the other side there without even looking at it. And then apply a smooth level that's about medium here. And we can see how that's rounded that out. One way to get a very consistent smooth is to select the entire object that you're smoothing. And you'll see that the result here, after I apply this, is that the edge around the cup will have a uniform fillet or a uniform round. So that's my preferred method for this particular use. So very quickly we've created a volume here off of the imported solid. What I'd like to do is open a portion of the file that is finished so you can see how the model would look after all 3 tabs are created. And here is the finished product. We have 3 tabs fit perfectly to the scanned data, and you can see that they also remain an even thickness all the way along as they wrap around the clay. This was done using that surface method where the surfaces are fit to the pelvis and also unfit from the pelvis to get around the acetabular ridge here. And that is how freeform is of huge benefit to modeling custom prosthetic implants. Thank you very much.